Okay, so we're looking at a little bit more about experimental design, and we're going to identify here today 3 types of experimental design. Okay, this is going to be number 1, something that we call completely randomized. Number 2 is something that we're going to refer to as a randomized block. And number 3 is something that we're going to call a matched pair. Okay, so these are going to be the 3 types we talk about. Completely randomized, randomized block, matched pair. Okay, so in a completely randomized experimental design, I have my sample of people. Okay, so I have my sample of people here. Let's say I've got like 18 people here, right? And I'm going to make 2 groups. I'm going to make a control group, and I'm going to make my experimental group. And what I'm going to do is I'm going to pick these groups completely at random. So I'm going to use like maybe a random number generator, and I'm going to randomly pick 1, 2, 3, 4, 5, 6, 7, 8, 9 people. So those 9 people are going to go into my control group. The other 9 are going to go into my experimental group. So part goes here, part goes here. And that is a completely randomized experimental design. Now, that may be suitable for some experiments. We'll look at the other 2 designs and see how they might work differently. Okay, so here is my randomized block design. Okay, so what I'm going to do is I'm going to take my population, but I noticed something about my population. Like this group over here might have a certain characteristic. Okay, and then I have another group over here who has another characteristic. Another group over here, and another group over here. So let's say maybe these people have an A blood type, maybe these people have a B blood type, maybe these people are AB in blood type, and these people are O. So these people may respond to my experiment differently because of their blood types. So I need a control group, and I need an experimental group. And I believe that there's the possibility that the treatment might affect different blood types differently. So what I'm going to do is I'm going to do random selection within the groups. So this group has 3, 6, 9, 10. So I'm going to randomly pick 1, 2, 3, 4, 5 people from this group and put them in my control. And then put the other 5 in the experimental group. Now, I'm going to do the same with each of the groups. I'm going to randomly pick 3 from here, put them in the control group, put the other 3 in the experimental group. Randomly pick 2 from here, put them in the control group, put the others in the experimental group, and then in my group of, what is this, this is 12, so I'm going to pick 1, 2, 3, 4, 5, 6 at random from this group. Put those in the control group, and put 6 in the experimental group. So now I have randomization, but I've done it over blocks so that I'm now controlling for blood type. So if blood type is going to have a different effect, I now have an experimental group that is guaranteed to have each of the blood types and a control group that's guaranteed to have each of the blood types. So this is a randomized block design. Third group is what we're going to call a matched pair design. So what I do here is, let's say I have this population. And I note that I try to find pairings within this group that are most like each other. So like, let's say this guy and this guy are close to each other. So I put one of them in the control, and I put the other one in the experimental group. Okay, so like this guy might be like this guy, so I put one in each. This guy might be similar to this guy, so I'm going to put one of those in each. And then I keep doing this. I keep trying to match someone in each group with, or someone in the group with somebody else that's very much like them. So the last one's there. And now I have a control group that looks very similar to my experimental group, and I can kind of keep them categorized one by one and see how that works out. So I have a matched pair going on here. Now, another way to do this is actually to say, what I'm going to do is I'm going to watch everybody in the group before the experiment. So this is the control group before the treatment. So all the befores are in here. And then I'm going to watch the same group of people and use a treatment on them and see what they look like afterwards. So I'm almost like pretending like these are 6 different people. Like these folks are the exact same people as these folks. These are the people who, what they were like before the treatment. This is what they were like after the treatment. But this is actually an example of a matched pair design. Okay, because here I have the before person matched with the after person. It's the same person, but it's just a matter of whether or not they had the treatment that's being tested in the experiment. Now, finally, there's something that can be done here that's really awesome when it occurs. If you can get identical twins, like sets of identical twins, that is like the ultimate matched pair experiment. Because I'd put one twin in the control group, put one twin in the experimental group, and then I have controlled for almost everything except for the treatment that I'm putting in the experiment. So twin experiments are extremely cool for matched pair design. Okay, so summarizing here. 3 groups, 3 types of experimental design that we're talking about in this class. Completely randomized, which is where you create your control and your experimental group, and you just randomly choose members of the population to be in each. 2. Randomized block. So in a randomized block design, we have pools of people that we are now putting into the control and into the experimental groups by random, but we're doing it within the pool. Okay, so this is like the blood type example that we gave. Number 3, we have a matched pair design. Where you try to put one person in each group from pairings until you have a full control and experimental group. Now, this can also be like people before they receive a treatment and people after. And the ultimate form of a matched pair design would be a twin experiment where you put one twin in the control group and the other twin in the experimental group.